Starting in the review packet. This first section is your power rules, and this is where that acronym MAD spam comes into play. So this tells us what we do with the bases and what we do with our powers as an operation. So if I'm multiplying bases, we add the exponents. If I'm dividing bases, we subtract. And if I am powering up, which is indicated by parentheses, then we will multiply. So mad spam. So we're going to go through a few of these together to practice identifying the base operations and the power operations. So looking at number 1, is that a foiling problem? Third block said yes, no, yes. That is not a foiling problem. So I think this was the problem on the homework quiz where I had students tried to distribute each of those monomial parts to everybody. These are all joined by multiplication. So what we're really going to do with these is kind of shuffle it around so that our like terms are next to each other. So this is all multiplication. I'm just going to be putting my like stuff together so that I can multiply them. So coefficients together, 6 with the 2, x squared with the x to the negative 4th, and then the y negative 2 with the y2. So nothing's getting distributed. I'm not introducing any plus signs. I'm just shuffling it around so that my like terms are by each other. So 6 times 2 is 12. X squared times x to the negative 4th. I am multiplying the bases, so I'm going to add those exponents. So x to the negative 2. Now, when we first learned this, I said you can resolve those bad attitude powers first, but I find it easiest, unless you're dealing with division, to wait until the end. So I'm just going to work with that negative 2 for right now. Now, the y's, I am multiplying the bases, so I'm going to add the exponents, and I get y to the 0. And now we need to simplify further. Who is getting that bad attitude power of negative 2? The 12, the x, or both? Only the x. So that 12 has an implied power of just 1. So when we go to resolve that bad attitude, we are going to send it to the downstairs to lose the attitude, and it's only the x, not the 12. Now, y to the 0. Anybody remember what y to the 0 is?
1.
It's 1. Anything to the 0 power is 1. So I have 12 times 1, or just 12, since this is multiplication. And then on the bottom, we have x squared. So when we send it to the downstairs, it loses the attitude and becomes positive. Now on number 4, we have division. We're still going to use mad spam, but this is a problem where before I do anything, I would resolve the bad attitude. Third blog didn't take my word for it, and they're like, why, Mrs. Caro? Because don't you just get x to the 5th on the top? Do we get x to the 5th on the top, the x's? Because those x's are separated by division, which means I would need to subtract those exponents. So 7 minus a negative 2 would give me x to the 9th. So it's a really easy trap to fall into. So as a general rule, anytime you have division, I would resolve those bad attitudes first. So that will give me x to the positive 2 on the top. And then x to the 7th will be right next to it. Next are coefficients. If I've got negative 9 over 27, we can take a 9 out of both of those, which will leave me with negative 1 on the top and 3 on the bottom. So negative 1 and 3. Now for the y4 over y6, you can subtract those, but a lot of times when the bigger number's on the bottom, I just think of taking out a GCF out of both of those. I can take a y4 out of both, which would leave me with a y squared on the bottom. So from here, my x's are joined by multiplication. Bless you. So we add the exponents. So I get negative x to the 9th. You can put negative 1x to the 9th or just negative x to the 9th over 3y squared. And there's our final answer. Any questions on those first two? Next one I want to go over is number 5. So this one's got a bit more going on. We do have a fraction, we do have negative exponents, but we also have two different operations that we need to carry out on the top. So on the top, these two are joined by multiplication. We're not going to do any foiling. We're just shuffling all this stuff joined by multiplying around. So I'm going to multiply negative 9 times negative 2, which is positive 18. X to the 4th times x to the negative 2. We are multiplying the bases, so we add the exponents. X squared. All over. Now on the bottom, it's kind of tough to see, but I am powering up by 2. So if I'm powering up, we are going to multiply the exponents. The real question is, how many exponents do I have in my parentheses? There's 2. So we've got the x with the power of 2, but that 3 has a power of 1. So we're not multiplying the bases by 2. We're multiplying the exponents by 2. So that becomes 3 to the 1 times 2 is 2. X squared to the 2nd, x to the 4th. From here, 3 squared is 9. So 18x squared over 9x to the 4th. 18 divided by 9. We take a 9 out of both of those. We are left with 2 on the top. For these, we take an x squared out of both of those. And we're left with x squared on the bottom. Why is my answer not 2x squared? Where's that x squared? On the bottom. So it has to stay in the downstairs or on the bottom. So just be careful when you're crossing things out and simplifying that you don't miss variables and that you keep them in the correct position. On number 7 and number 8, these are polynomial operations. Best advice here is just identify what operation you have going on. I am adding these two polynomials together, so you are just going to combine your like terms. Nothing happens with the exponents, no foiling involved. Number 8, though, these are joined by multiplication. So this is going to be a super foiling problem. I went over number 9 with third block. I think I'm going to go over number 10 with you guys. So on this problem, I am dividing by a monomial. This is not long division. This is not synthetic division. This is division distribution. So we are going to take every chunk on the top divided by this one chunk on the bottom. This gets divided, that gets divided, and that gets divided. I said you could show the full work if you wanted to, or you can kind of cross off as you go along. It's totally up to you what you want to do. Some students find it's less messy to do it in their heads. Other students like to see the full worked out problem. So I'm going to write out all the steps. And while I am doing that, see what you can do with this problem. So I'm showing taking the top chunk divided by 5a cubed c squared d. The second chunk, I'm just checking myself here, divided by 5a cubed c squared d minus 5a 4cd divided by chunk 5a cubed c squared d. So now we have broken this up into kind of, into 3 mini problems similar to the ones that we did above. So I've got this stuff that needs to be simplified, this stuff that needs to be simplified, and that stuff. So 20 divided by 5 gives me 4 on the top. So 4. The A cubes cancel each other, and they cancel to be 1. 4 times 1 is still just 4. The B, nothing to cancel out with, so B is going to stay on the top. The C, I can take out of the top and the bottom, which leaves me with a C on the bottom. My D's cancel. Goodbye. So, folks, I've done the first part of this. I want you to see if you can do the other parts. Careful with your signs when you're simplifying. How did we do on that one? 4b over c minus 2d over ac minus a over c. Any questions? So crossing off things as we go. You can subtract top minus bottom, but I just think about taking a GCF out of the top and the bottom. Let's go ahead and move to the second page. And this is where we do our throwback to long division and synthetic division. So as I've mentioned earlier in this unit, you will have to show both of these on the test. And if you're like, yeah, but I'm just going to do it with synthetic and then just kind of make my work look okay for long division. I will be checking that long division work carefully. You do need to make sure that it is an exact match and shows exactly what you are doing. So another warning, there are 2 problems that you won't be able to check with synthetic division. Our only limitation for synthetic is that we can only use it when the coefficient of the divisors x is 1. So these 2 long division problems have a coefficient of 2 and 7. So you would not be able to check these using synthetic division. Long division is the only way to go on those. So couple of reminders with all these division problems. You should always check for your power placeholders first. So whether long or synthetic, check for power placeholders. Check for power placeholders. The other thing that is consistent with both is that we express our answer as quotient plus the remainder over the divisor. And a lot of times students will forget that plus sign. So quotient plus the remainder over the divisor. So we're going to go ahead and start with number 12, checking for power placeholders first. We go to 1 constant, good there, 1 constant for our divisor. So no power placeholders necessary. So we are going to write our divisor on the outside of the house, 2x minus 7. And then 2x squared plus 7x minus 3. When's our test, folks? Tomorrow. So if you were looking at the back board, that is already our Unit 6 stuff. So the last 2 pages of the Unit 5 homework are due tonight on Canvas, as is the review packet. So those 2 things are due tonight. And if you want to turn them in during class tomorrow at the beginning of class, that's fine too. But those new due dates are for our next unit. All right, folks. So How does long division work? Excuse me, our leader term is the term that has x with it, and that does all the deciding of what goes on the dividing house. So the tag-along term comes along for the ride, but our main focus is on this 2x. We also cover up the back end of our dividend, and what we ask ourselves is 2x times what on the dividing house gets me 2x squared. 2 times what gives me 2? 1. And x times what gives me x squared? X. So you can write 1x or just x. Leader term decides what goes on the dividing house, and we're just trying to get a match with that first term. Then I multiply by both the leader term and the tag-along term, and that gives me my first line. 2x squared minus 7x. Enclose in parentheses and subtract both of them. So 2x squared minus 2x squared, 0. 7x minus a negative 7x makes this a plus x, so 14x. Then we bring on down our next term, and we repeat the process. So 2, ignoring the tag-along term, ignoring that negative 39. 2 times what on the dividing house gets me 14? 7. X times what gets me x? We've already got x, so I only need a plus 7. Times the leader term, 14x. Times the tag-along term, negative 49. Enclose in parentheses and subtract. 14x minus 14x, 0. Negative 39 minus a negative, so plus 49. So 49 minus 39 is 10. Is 2x minus 7 a factor of the polynomial? No. We didn't get a remainder of 0, so yep, there's a remainder there. So to write our final answer, we are going to do the quotient, x plus 7. Switch this. So x plus 7, and then plus our remainder, 10, over the divisor, 2x minus 7. So making sure your answer is a polynomial and that our remainder over the divisor is joined to that quotient by addition. Any questions on the long division? Super great. All right, folks. Next is synthetic division. Now, we've been doing synthetic division the past couple days, plugging in the roots, getting the remainder of 0. But that was when we were synthetically dividing by factors. So when I divide by a factor, the root goes in the box. So if x minus 7 was a factor, what would go in the box? 7. So when I am dividing these just by regular binomials, we need to flip the sign. When we put the number in the box. So if I want to divide by x minus 7, we put 7 in the box as if 7 was the root of this. So 7 in the box. So on the next page, not the next page, page after that, the back page, where it's solving, I would draw your little synthetic division box, and I would say root. The root goes directly in the box. So I'm not flipping the sign here. And if you do mix up, you'll be like, hey, I didn't get a remainder of 0. That's a big problem. But over here, I'm not necessarily going to get a remainder of 0. I'm not dividing by factors. I'm just dividing stuff just for the fun of it. So when you are just doing a regular synthetic division, you flip the sign of the constant number. So coefficients, checking for placeholders. 13, 2, 1, constant, 1, constant. So 1, negative 13, 40, and 18. So with our solving problems, I whip through these pretty quickly because knowing I should get a remainder of 0 is a good way of checking myself. These, I'm probably going to have a remainder, So I'm going to go ahead and go a bit more slowly through this one. You always start by bringing down that first term below the line. From teaching Algebra 2 in years past, so I know that that often gets missed. Then it's times the box, add straight down. Times the box, add straight down. Times the box, add straight down. And what's the degree of our new polynomial? It's 2. Our starting degree was 3. And anytime we're dividing, whether breaking down a polynomial into its factors or just breaking down a polynomial for fun, it always goes down by 1. So then we'll have x squared minus 6x minus 2, the constant, and that last term is our remainder. And we express that the same way we did for long division. Plus the remainder over the divisor, over the x minus 7. And there's synthetic division. All right, folks, on to factoring. I think I'm going to stop the video here.